Hello everyone. In today's topic, we will see Module 4 Communication using Arduino boards, Lecture 4 I2C Communications. I2C Communications. I2C terms basically stands for Inter-Integrated Circuit. It's a serial bus interface connection protocol. It is also called as TWI interface, that is two-wire interface, also termed as TWI. Since it uses only two wires for communication, those two wires are SDA and SCL, whereas SDA stands for serial data and SCL stands for serial clock. I2C is a acknowledgement based communication protocol. So that is what SDA is called as a serial data acknowledgement. So that is transmitter checks for an acknowledgement from the receiver after transmitting the data to know whether the data is received by the receiver successfully or not. So the efficiency of data communication can be achieved. I2C works in two modes, namely master mode and slave mode. SDA serial data wire is used for data exchange in between the master and slave device, whereas SCL, that is serial clock, is used for the synchronous clock in between the master and slave device. Master device initiates communication with a slave device. It requires the slave device's address to initiate conversation. The slave device responds to a master device when it is addressed by a master device. The I2C device has 7-bit or a 10-bit unique address. So each individual device has different addresses. So each I2C device has 7-bit or 10-bit unique address. So it access these devices, a master must address them by the 7-bit or 10-bit unique address. So whenever the master wants to communicate with any of the slave device, it has to address that particular device with this 7 or 10-bit unique address. I2C is used in many applications like reading real-time clock RTC, accessing the external EEPROM memory while at the time of interfacing the external memory to the devices. It is also used in sensor modules like a gyro and magnetometer, etc. applications are based on I2C communication protocol. The conceptual wiring diagram of I2C will look like this. The wires SDA and SCL needs to be pulled high with the pull-up resistors because the internal pull-ups are not available onto this particular pins. So whereas you can see the slave device 1, slave device 2, slave device 3, or similar to this, multiple slave devices can be there which is having different addresses as noted into this particular figure, and there will be one master device. So this will be the master one, and onto the SDA and SCL pin taken out parallelly we can connect the several devices. Any sensor or devices we can connect onto this by using the I2C concept. So below it, the two Arduinos are connected using the I2C protocol, that is the SDA and SCL pins over here are connected. You can see the ICSP header, similar pins are available over here. So onto this pins are utilized, whereas on the analog channel also the same pins are visibly mentioned onto the board of these Arduino Uno and different Arduino boards. You can make use of either of this. Only one I2C pair is available, so we have to make the connection with the availability. So this is a way how you can wire the I2C connection for establishment of the I2C protocol. So I2C protocol uses two lines for communication. Serial clock SCL, it is a clock signal. Data will be sent to the other device on a clock tick event. Only master device has a control over this SCL line. Slave will not having this control. Master can enable the clock and send it. Serial data SDA, it is a serial data line which is used for exchanging data between master and slave device. I2C bus is an open drain configuration, which means they can pull the corresponding signal line low but cannot drive it at high. hence the line will go into unknown state. In order to avoid this, pull-up registers need to be get connected on SCL and SDA pins. This value of pull-up register may varies as per the need of application we are trying to interface. We will see the sample program which was previously written by in my ID. You can see for establishment of this I2C protocol, you need to use this wire.h header file to be included in the program. Then in the setup of this Arduino program, you have to mention wire.begin as for enabling the I2C connectivity, establishment of this wire protocol. Then you have to declare the byte variable x. You can take any variable name. I have declared it as byte, initialized to 0, and after that in a main loop program I have mentioned over here that wire.begin transmission, this is a device ID, basically the address which we have discussed, whereas the wire.write will put the string, sends the 5 bytes onto the element for transmission, right? And wire.write x will definitely writes the whatever number of bytes are there in x one by one onto this line. So wire.end transmissions, once the 5 characters transmission gets over, drop, this will stop the transmitting. So one by one the character gets ends. So once the end of the character gets done, so total number of characters whatever we are transmitting over here was done, until and unless it will not get, it will get incremented its value. Once it is done, we will have some delay after each character and will again repeat the program. So this is how the I2C master program can be written, whereas slave program need to be get initialized in the way by including the wire.h file in this part also. This in a slave device, this program should be loaded, whereas in setup we have to set up it for device ID for address 8. Then on receive event need to register event as perform is at receiving the data. Serially communication rate of communication is 9600, which is also a part of serial communication. And in void loop function we have decided the serial interrupt over here. So receiver event when carried out, so how many basically characters we need to receive from this. So this is what one of the integer is declared over here. So in this program the wire read function receives the byte as a character, whatever characters are there we will receive over here as a character value in C memory, which is a character type, and prints that onto a serial monitor. So receive byte as an integer. So in this case this wire.read will receive that as an integer and put it into the variable name as x, which is an integer declared, and it will print that value which was x integer on the screen. So whatever there inside the x will be printed onto the screen of the serial monitor. So the whatever transmitted from the master will received by the slave, and similarly ways onto the serial monitor it will be printed onto the screen. So this is how the program can be done for different master and slave concept establishment of I2C communication protocol. While programming section you will understand the different functions in detail. So this is the basic overview of how the setup can be done for serial communication basically. So this is how I2C communication can be established with the multiple devices and communication carried out. Thank you.